and share and subscribe and like.
In this new video, we discuss about two-dimensional heat equation. For that, we have considered a plate having length and breadth. Here, the heat is flowing in the plate, and therefore, at we are heating this plate. Therefore, the temperature of the plate is increasing. And suppose u of x comma y denote the temperature at a point x comma y at any time t at a time t, then the equation of heat flow is del u by del t equal to c square into del 2u by del x square plus del 2u by del y square. Now, in a steady state form, u is not changes with time. U not changes with t. It means u is independent of u. If u is independent of u, then its derivative del u by del 2 is obviously equal to 0. If derivative equal to 0, then we get c square into del 2u by del x square plus del 2u by del y square equal to 0. And this gives us del 2u by del x square plus del 2u by del y square equal to 0. And this equation is called as Laplace equation. This equation is called as Laplace equation in two dimensions. We want to solve this equation. Here again we apply the method of variable of separation. Suppose u is a function of capital X, capital X is function of capital X, capital Y is a function of small y, then del u by del x equal to x dash y, and x dash means this is equal to dx by dx. Del 2u by del y square del x square equal to d2x by dx square into y. Del u by del y equal to capital X into dy by dy, and del 2u by del y square equal to x into d2y by dy square. Now substitute this value in the given equation. We have y capital into d2x by dx square plus capital X into d2y by dy square equal to 0, or capital Y into d2x by dx square equal to minus capital X into d2y by dy square. You can see that we can separate the terms x and y. That means transfer this y to right side and this x to left side. We get 1 divided by capital X into d2x by dx square equal to minus 1 divided by y into d2y by dy square. So we have this value. Now we equate this with minus p square. Here we take minus this side and we equate this with constant minus p square, say. If we equate this, we have two different equations. One is d2x by dx square equal to minus minus will be plus. So you can see that here this is here we take minus on this side, and you can see that this is minus p square into x. This is one equation, or d2x by dx square equal plus p square x equal to 0. And second equation, d2y by dy square equal to minus minus plus p square into y, or d2y by dy square minus p square y equal to 0. So let us call this equation number 2, suppose, equation number 3 suppose, and this is my Laplace equation. These are the second order ordinary differential equation, and we know that how to solve this ordinary differential equation. First, for solving this ordinary differential equation, we have to find the auxiliary equation of this equation number 3, equation number 2. So from equation number 2, we have auxiliary equation is m square plus p square equal to 0, and m square equal to minus p square, m equal to plus or minus I into p. This gives us x equal to solution c1 cos of px plus c2 sin of px. And from equation 3, we have m square minus p square equal to 0, m square equal to p square, m equal to plus or minus p. This gives us y equal to c3 e raised to py plus c4 e raised to minus py. Then the final solution will be, this is equal to, we have c1 cos of px plus c2 sin of px into c3 e raised to py plus c4 e raised to minus py. This is the solution of Laplace equation. Now friend, when we impose certain conditions on this equation solution, the solution will be converted into simple one. That means at initially, when at point x is equal to 0, we have the temperature is also equal to 0. That means at certain point the length we have taken, we are measuring the length from x is equal to 0 to x is equal to L, and at the end point we have the temperature is equal to 0. Temperature is equal to 0. This gives us when x is equal to 0, u equal to 0. So if we impose this condition on this solution, you can see that 0 is equal to, put x equal to 0 here, this is c1 into c3 e raised to py plus c4 e raised to minus py. And look at this, here c3 c4, this term cannot be equal to 0, so only possibility that c1 equal to 0, this implies c1 equal to 0. Therefore the using this condition, equation 4 becomes, this equation will be reduces to c1 0 gives us u equal to c2 sin of px into c3 e raised to py plus c4 e raised to minus py. This is our equation number 5. Now let us apply another condition when x is equal to u, u equal to 0, x is equal to L. 0 is equal to c2 sin pl c4 e raised to py plus c3 e raised to py plus c4 e raised to minus py. You can see that c2 cannot be 0, and this term is a variable term, so it cannot be equal to 0. Only possibility is that sin pl, which is now converted into constant term, this must be equal to 0. Sin pl equal to 0, but sine of n pi is also 0 for n is equal to 1, 2 up to 3. This gives me pl is equal to n pi and from this we have P equal to n pi divided by L. Then equation 5 reduces to u equal to C2 into sine of n pi divided by L into x, C3 e raised to n pi divided by L into y plus C4 e raised to minus n pi divided by L into y. Again, y is equal to 0 at the starting point. Whatever may be the breath, the temperature is equal to 0. Yet it is not started to heat. Therefore, when y equal to 0, u equal to 0, you can see that if we put this y equal to 0 and u equal to 0 in this equation number 6, we have 0 equal to C2 into sine n pi x divided by L, C3 plus C4. We have now this, since e raised to 0 equal to 0, e raised to 0 is equal to 1. Okay friend, then see here C2, as already I have told you, it cannot be equal to 0. C2 becomes 0, then the whole term x will be 0. This is a variable term, so it cannot be equal to 0. Therefore only possibility is remain to us is that C3 plus C4 must be equal to 0, and gives us this gives us C4 equal to minus C3. Substituting this value in equation number 6, if we put this value in equation number 6, we arrive at the point that this u equal to C2 into, let us take C3 as a common, into sine of n pi x divided by L into n pi x into here e raised to n pi y divided by L minus e raised to minus n pi y divided by L. Again, the breadth of this plate is fixed, so let us take that breadth is equal to a, and at the breadth at the end point, at that end points, that means if this is the plate, at this point this is x equal to 0 and x is equal to L here. So at this point there is a no initial temperature. At this point the plate is insulated, so there is a no temperature. Again, we have taken this is y equal to 0. At this point there is a no temperature, u equal to 0, and if we take this is y is equal to, at this point there is a no temperature. Okay, so this value of u equal to 0 equal to C2 into C3 into sine of n pi x divided by L. Now instead of 0, if we take this is equal to sine of n pi x, n pi x divided by L. So let us take this value. This is the initial condition which we are now applying to get the values of constant. Okay, so we have two constant now in this equation, C2 into C3. Suppose this value here u is, suppose my u equal to sine of n pi x at this point, n pi x divided by L. If this condition to get the values of C2 and C3, then we have sine of n pi x divided by L equal to C2 into C3 into sine of n pi x divided by L into e raised to n pi a divided by L minus e raised to minus n pi a divided by L. Okay, now see here n pi x will be cancelled, and we have C2 into C3 equal to 1 divided by e raised to n pi a divided by L minus e raised to minus n pi a divided by L. Okay, so let us put this value here in this equation. Suppose this is an equation number 7. We put this value in the equation number 7 with these initial conditions. We have taken 4 initial conditions for this Laplace equations, and to get the values of the constant. Then we have here u is equal to, you can see that u equal to sine of n pi x divided by L into e raised to n pi y divided by L minus e raised to minus n pi y divided by L divided by e raised to n pi a divided by L minus e raised to minus n pi a divided by L. Okay. So if we divide this by 2 and this by 2, this will gives us a hyperbolic value, and hence this function sine n pi x divided by L into sine h of n pi y divided by L divided by sine h of n pi a divided by L. So this is the solution of these Laplace equations, where we have all the constants we have calculated by applying the initial conditions.
Hello guys, thank you for watching video.